I'm just a normal developer advocate. I'm nothing any special. But what I want to talk to you today about is WebAssembly. Because WebAssembly is a technology that I'm incredibly passionate about. And the reason that I'm really passionate about it is that I think WebAssembly is one of the greatest future technologies that we're going to see a lot of use for in systems programming. Not in a web browser, but I think WebAssembly is one of the brightest technologies which is going to enable things like plugin development, cross-language enablement, and all sorts of things like that. And I kind of want to explain those concepts to you today. So we're going to kind of run through a very high level what WebAssembly is, how you can use it in the kind of the phase of system development, some of the gotchas and some of the problems that you're going to have with it. Now, one of the premises of this talk is that WebAssembly can run anywhere. So I decided to make WebAssembly run in Minecraft. All right, so what we're at. Why WebAssembly? Well, the thing for me about WebAssembly is that I want to be able to leverage lots of different libraries. I mean, have you ever found a library and you're like, that's perfect. It fits exactly what I want to do, but it's in the wrong language. You know, the amount of times that happens is quite often. And you just think, well, it would be great if I could just use that language, but no, I've got to find a port in my current language, and I've got to kind of work through, stuff like that. And then there's another kind of aspect, and that is, well, what if you want to write a plugin system? What if you want to allow people to extend your application? So I'm predominantly a Go developer. So if I'm going to write a plugin system for my application, you're going to have to write Go. Now, I don't know if you're a Go programmer or not, but it's potentially alienating quite a large amount of people who can potentially, contribute to my project. And then there's kind of like a bunch of problems when it comes to libraries. So like we already said, they're not mixable. You can't just run and import a Go library into Java. Like you've got to kind of deal with horrible things like potentially you want to import C library, you've got to deal with C bindings. Bytecode languages like Java, you can't just distribute a library, you've got to distribute the JVM. And then even sort of compiled libraries or kind of like plugins have got to be kind of specifically built for the architecture that they're going to run on. Now, that's a little note to myself so I didn't forget. So I'm Nick Jackson, I'm a developer advocate at HashiCorp, and this has literally been one of the things that I've been trying to solve throughout my entire career. It's a problem that I've kind of encountered a number of times. It's a problem that I've tried to solve in a number of different ways. And I've not really seen a good solution around this as yet. But WebAssembly is the closest thing. So what is it? What is WebAssembly? So the first thing is, it's not a language. Not as such, anyway. You don't write WebAssembly. WebAssembly is designed to be a kind of a binary code format, and it has a sort of an associated textual format. It's designed that you compile your Go code, and the compiler for that will output WebAssembly. You don't write it directly. Now, sorry about the potato quality here, but we'll kind of like dig into this a little bit. But conceptually, where did it come from? Well, it did actually come from the web, hence WebAssembly. So the initial kind of foundations were around a project called ASM.js. And ASM.js wanted to enable people to do things like run C++ or C libraries inside of the browser. Well, why? Well, for example, you want to use something like libjpeg. You want to be able to use something like that to be able to change the compression of an image. Now, features that JavaScript doesn't necessarily give you. ASM.js would allow you to do things like take a C application and through a transpiler, it'll convert it into JavaScript. So then you can basically run C in your browser. Now, WebAssembly kind of follows on from this idea, but takes it one step further. Because conceptually, one of the problems with doing that is that you still need a Java runtime. because you're, sorry, JavaScript runtime, because you're still running JavaScript. Now with WebAssembly, and again, we'll look at this in a bit closer depth once I get past this terrible idea of actually putting slides in Minecraft. But you can take a function like this, so a really simple function in Go, and what you can do is, again, through the compiler, you can output WebAssembly. So this is WebAssembly text format. Again, not something that you genuinely have to touch. Now, what that means for kind of like, as opposed to the kind of the ASM.js approach is, you no longer need to run a JavaScript runtime. You do need a WebAssembly runtime, but, so what is WebAssembly? We're going to look into all these things, but it's executed by a runtime. So you have a runtime that executes the WebAssembly text. It compiles it on the fly down to native machine code, so it's platform architecture independent. It's fast, and the goals of the project are to provide near-native performance. Now, whether that is achieved, I think it's very possible that it can be. And in fact, you might actually get better than near-native performance in some cases. So consider you're writing Python for data science perspective. If you can compile that Python down to WebAssembly and then run it on a hyper-efficient WebAssembly runtime, you might get better performance than actually executing the Python on its own. The benefits are portability. You write something once, you run it many times. So kind of some of the languages which you've got a compile target right now, and I want to put a big caveat around all of this, that it's an evolving technology. Some of the kind of the supported languages are better than others. So you've got Go through TinyGo. Rust, probably one of the better supported languages because you have the kind of the runtime and the work that Mozilla are doing is kind of oriented around Rust, so that's pretty tightly supported. C and C++, the Emscripten framework, which kind of like came out of that ASM.js, is very mature, and the ability to sort of compile your C, C++ into WebAssembly through Emscripten works incredibly well. Assembly script. So assembly script is not JavaScript. It's JavaScript-like. It doesn't, at the time, kind of like really interact with JavaScript code directly. So you couldn't just take like Node and push it through assembly script. But there's movements to kind of make that better. Python through CPython. Java. I got Java to work. It's kind of an evolving thing. There didn't seem to be any really good open source alternatives in compiling Java to WebAssembly, but it's there. .NET and like literally many, many more. Now, in terms of the runtime, you can embed the WebAssembly runtime into pretty much any language and on pretty much on any platform. You can even run the WebAssembly runtime on embedded devices. It's really, really very, very portable. This way, Nick. Now, we're going to get to the point of this all. So my buddy Eric and I, that's Eric, handsome fellow, I'm sure you agree. But my buddy Eric and I have got this thing called HashiCorp. And what we do with HashiCorp is we try to kind of explain technology in a fun way through Minecraft, because we're big Minecraft fans, and we're also big fans of modding in Minecraft. Hence why I'm doing this talk in Minecraft, because when I said, hey, you can run WebAssembly anywhere, can you run WebAssembly in a Minecraft module and inside Minecraft? Well, I hope the answer is going to be yes. Otherwise, this is going to be pretty embarrassing. But my buddy Eric's not here today, but he did send me an email, and it says, so, hey, Nick, sorry I can't be with you today. I need to get my cat neutered. I saw your demo, thought it was a bit unadventurous, so I mixed it up a bit, and I've set you 3 challenges. Love, Eric. Well, thanks, Eric. So let's kind of rush over to that demo. So the kind of the principle of what I'm doing here is in terms of Minecraft is extensible. So you can mod various elements of Minecraft. You can write extensions to it. Now those extensions are written in Java. So I've created an extension which can actually run WebAssembly modules, and the output from those WebAssembly modules I'm turning into redstone signals. So I have my WebAssembly module here. It's going to run If it works, it's going to open the doors. And let's see what I've got to do on this challenge. But I've got to write and run a WebAssembly application by hand and don't make any type. Thanks, Eric. Yeah, well, and he's the gates of doom. Thanks. There's like everything you need to be filled full of a little bit of confidence, and it's right there. So let's take a look at how this works. So I'm going to show you some Java code. I'm going to show you a bit of Rust code, and I'm going to show you some Go code. But right now, we're going to walk through how the WebAssembly runtime works inside of Java. Now, I don't want to concentrate too much on this portion because you can kind of find this code and cut and paste it from the internet. What I want to concentrate on are the gotchas, which kind of make working with WebAssembly a little bit more difficult. But I'm using the WasmTime runtime here, and I'm using the Java bindings for that WasmTime runtime. So when I click the run button inside of here, inside of my Minecraft mod, I'm going to invoke the WebAssembly runtime, and I'm going to execute a function. So let's look at the setup on that. So to kind of get a WebAssembly runtime inside of your code, you need to initialize it. You need to set it up. So that's what we're doing here. And then what I need to do is initialize a store. So the store is going to contain things like the memory, and it's going to be related to the instance. Now, WasmTime, or whether you're using Wasm or kind of Go or Java or Python, this process is going to be exactly the same. It's just kind of like a different language difference. So then I'm going to kind of look at how I execute my function. So what I need to do is I need to create a linker. So why do I need a linker? So what a linker allows me to do is it allows me to do things like link different WebAssembly modules together. It allows me to have host functions which are running in the runtime, make them accessible to the WebAssembly module, and things like that. And in fact, I'm doing that here. So we'll talk about WASI in a little bit, but WebAssembly system interface is kind of the thing that makes all of this possible. It's an extension to the WebAssembly standard. It gives you things like the ability to access files, and hopefully at some point it's going to give you the ability to do things like access network sockets. So I'm instantiating that. I'm setting up my module. And then what I'm doing is I'm just getting the parameter, which is coming from my interface. I'm just casting it to an integer. And then I'm going to get the function. So the runtime needs to get the function from the WebAssembly module. And that's what I'm doing with this get call here. Now, in terms of Java, like there's probably a better way to do this. I can kind of make Java work. I wouldn't ever say I'm an expert, but kind of in principle, what I'm doing is I'm basically selecting the correct function to execute based on the parameters that I have. And then I'm going to call it. The runtime is going to execute the WebAssembly module. It's going to give me the result back. I'm going to get that back. That's going to enable a redstone signal, and hopefully my demo is going to work. So let's look at this first demo. So what we need to do is we need to implement WebAssembly in a textual format. And that looks like this. So I'm not going to do any typing because that will just lead to disaster. But this is the WebAssembly text format. So quickly kind of running through this. Again, not something you genuinely need to ever look at, but it's really useful to have an appreciation of what's going on for when you need to debug. So I'm defining a module. It's list-based. Then I'm going to define a function. Now, function here called add, it's an internal function reference. I specify 2 parameters, and the parameters here are integer 32, so 2 input integer 32 parameters, and 1 integer 32 output parameter. So, first gotcha. WebAssembly does not have a complex type system, yet. WebAssembly's kind of type system is very, very sort of primitive. You're dealing with integers, floats, things like that. even 64-bit integers is only kind of supported by a subset of the kind of the runtimes. It's not sort of ubiquitous everywhere. And that's going to change. But for now, that's something that we've got to deal with. So then what am I doing? So I'm getting the kind of the parameter, and I'm popping it onto the register. So I'm doing the same with the second parameter, and then I'm going to add those two together and return that. So that's what the function's doing. It's as simple as it could be. Now, the interesting bit, I think, for users, and kind of where WebAssembly is worth looking at, is this export. Now, what the export declaration there is saying is, I want this internal function add to be exported for consumption with the name sum. So let's save this. Now, I've got this kind of already set up here. So I'm going to run that sum.what, the WebAssembly text format. I'm not naming the module. I'm going to execute the function sum with the parameters 3 and 4, which should equal 7, and it's worked. So part 1 of the demo is over. Now what's happened there, the WebAssembly runtime inside of Minecraft has executed the WebAssembly function that I've literally just written. It's done the evaluation correctly, and it's opened the gates of doom. So what's the next step? Well, let's have a look and see what Eric has in store for us. So I guess he wants us to take a little ride on this roller coaster here. You cannot believe the amount of time that I spent doing this. This was like way more than anything else. The amount of weekends and tears. Like Redstone programming is way harder than anything else. And okay, well, so that's, oh, whoa, I don't want to do that. I don't want to go down there. That'll totally break my demo. So let's take a look. Let's see what Eric's got for another challenge. So he says, create the classic hello name application. Hint, you need to handle strings. And he calls this the jaws of death. Okay. So just a little bit ago, I kind of talked about the fact of strings. String is not a type which exists in WebAssembly. You've got numbers. So how do you handle strings? Well, thankfully, what you do have is the ability for the runtime to read and write to a WebAssembly module's memory. And because I can read to the memory, what I can do is if I can get a pointer to a memory location, I can write the string as a series of bytes using null-terminated C format into that memory. And I can do the same thing for writing it out. So it's a little bit of a workaround, but again, WebAssembly type system, it's work in progress. It's going to get better. But let's give it a go. So the first thing that I need to do is I need to be able to create a function which is going to enable me to write from the WebAssembly memory. And that's going to look like this. So what this is going to do, and I'm going to walk you through here, is it's going to call a function which is going to allocate some memory inside of the WebAssembly module. It's then going to convert the string into an array of bytes. It's going to write it to that WebAssembly memory. It's going to null terminate it with a 0 byte, and that's it. So it's not actually that complicated. So we can kind of go through and we can just kind of fill out our code. So now, when we've got this ability here, we can also add the ability to now kind of handle our complex types. So inside our code, I can now handle strings, because when I get a string, I'm going to set that string into WebAssembly memory. Now, what I also need to be able to do is to be able to kind of not just write that memory, but I need to be able to read it. So I can define another function. And what this function is going to do is exactly the opposite of the write function. It's going to read a sequence of bytes from WebAssembly memory, and it's going to convert it into a string. So let's put that in. Now, what's the next thing we need to do? Well, I need to be able to return that string. So if I just go up here, rather than just kind of returning that integer, I'm going to return my string. I'm going to save that. And now we can look at how we handle this in the actual code. So while I'm kind of doing that, what I'm going to do is I'm going to restart my runtime, because I'm just recompiling this code while I work on the WebAssembly module. So the WebAssembly module. So what I want to be able to do is I want to write a function in Go which writes a string. So the string, or the function, is going to look like this. Now, let's kind of like break down this. But what I'm sort of doing is I've written a Go function. abi.wasmString is a type in Go that ultimately is just a pointer. I've written some kind of SDK around this to make kind of reading and writing those strings easier. But when I call hello, I'm actually just calling a pointer. So if I go over here, and I'm just going to import my ABI. I'm just going to save that. And then while we're waiting for this to load, we can take a look at what that ABI actually looks like. So what it looks like is this. So all I'm doing is just creating pointers and reading memory and writing to them. So it's really sort of straightforward concepts. Now, over here, we can now test to see if this is going to work. So I'm calling GoString. I want to call hello. And I want to test it with hello, Nick. And what I'm also going to do is I'm just going to remember to compile the module, because that might be useful. Oh. Well. All right. So compiling it, I'm compiling with TinyGo. So TinyGo is basically taking the Go code, and it's going to turn it into WebAssembly text format. When I kind of go back over here, and now when I run it, well, there we go. So that's kind of worked. So I've managed to kind of write a WebAssembly function that deals with a string. Now, the next bit is the real challenge, which is, can I get through the last demo in 6 minutes? I think I can. But first, let's see what the jaws of death is all about. So what is this going to work? Well, that surprises me. But oh, it's all dark. Okay. So what we need to do next is have a look at Eric's next challenge. So his next challenge is we need to write a WebAssembly application in Rust that can execute some Go code to decrypt an image. Okay. So hint, you need to understand shared module memory. Now, what he means by this is that module memory in WebAssembly is actually separate. So the WebAssembly module for the Go module has a different memory space to the module for Rust. So the Rust code can't write directly to the Go module. So how are we going to pass a string across the boundary of two modules? What we're going to do is we're going to use a little bit of a hack, a workaround. And we're going to use another feature of WebAssembly, which is that we can call functions on the runtime in the host. That allows us to call a host runtime function. The host runtime function can then set the memory on our behalf. So let's go through and let's add this. So the first thing we want to do is let's take a look at our Rust code. So what I want is I want to be able to use a function inside of another module. And I can do this by kind of using this declaration. So I'm basically importing the encrypt and the decrypt function from a Go library, and then I can use it. And I can use it in exactly the same way as if it was a native function. Now, the problem with this is that I can't just do the whole string trick that I was doing. I need to call a host function to set the string in the Go function's memory, and then the Go function can then decrypt that. And look, I didn't say it was going to be easy, but it does work. And then we're going to call the decrypt. So we need to kind of add, again, some stuff to our runtime. So let's go do that. So we're going to add a new function here. And what this function is going to do is this function is going to be able to get a module string. And it's basically using the same get string and the set memory, but it's exposing it as a host function. Now, a host function, you can write any of these. So the runtime can expose an ABI to your WebAssembly modules. So we can write our host function here, and then we add it to the linker. So what we're now saying is we're saying we want the runtime to expose the method setString for module to any module that it's running. So back over in Rust, we can now import that host function. And that kind of looks like this. So it's that same sort of extern C, but I'm not using the module declaration because I'm just importing it direct from the host. So again, let's run this. And while we're doing that, let's have a look at the image that Eric wants us to decrypt. And it looks like, if I can find it, like this. So it's not, we can't see it, we can't read it. It's an encrypted image. So we're using a couple of the WASI capabilities here. What we're doing is we're using file system. So file system. WASM modules don't have a file system. WASI can provide a file system through its system interface. So again, when your code is compiled, it's kind of replacing all of those native file access methodologies, and it's kind of replacing it with a kind of a link to WASI-libc, as opposed to kind of the native methods. So we're going to call decrypt image. I'm going to use my key, which is the top secret password for the image. The input parameter is encrypted, so the slash, it's because of the file system. Decrypted is my output. Expected result is 0. That seems to have worked. We have some fireworks. So did this actually work? and we have decrypted, and then it's worked. So what we've just done there is we've just used Go's crypto library, compiled to WebAssembly, and we've leveraged it from Rust inside of a Java runtime. And if that doesn't break your brain, I don't know what does. But you know, the potential of this is incredible. In summary, WebAssembly gives you all of the things I'm promised. You know, it's going to take some time to get there. Complex types is a problem, networks is a problem, but we're kind of getting there. I've created a little repo here for you. This has got all of this code in. It's got my example Go code, my Rust code, and stuff like that. So if you want to kind of have a look at how you can kind of use this, okay, I used it in like Minecraft, but like you could have done this in a microservice. And thank you very much for watching. And that demo worked.